So, hi everyone. Thank you for joining us. I'm Scott Sumner, the CMO at Cadiz. I'm here with Boris Rogier, our Chief Operating Officer. And today we want to take you through a really exciting topic for a lot of us who are into IT observability. It's what is digital experience monitoring? And it's a new domain for a lot of people, and it's really a reinvention of how we see the user experience and all the components and the infrastructure underneath it that affect it. So we'll be taking you through this day and giving you an overview of that, as well as a live demonstration of what digital experience monitoring looks like in action. One thing we've learned when we see Gartner and other analysts and then our customers talking about digital experience monitoring is a whole new way of looking at things because of the way that the IT infrastructure and the cloud has changed and the way we work today, the way people access applications, the way they're hosted. With the advent of applications and their now dominance in terms of being 80% of what businesses use to get their jobs done each day, migration to the cloud, platform as a service, work from home now becoming very popular and hybrid working. So keeping track of that user experience as they move back and forth from the office to remotes, the reliance on things like SD-WAN and direct internet access and zero trust networks all are complicating what would normally be addressed by traditional observability tools. So digital experience monitoring is designed to address that space, to proactively allow IT teams to optimize the digital experience, resolve issues very quickly when they come up, and help them manage the third-party vendors that they're really dependent on right now in terms of delivering business applications and productivity. So when you take a look at the objectives for digital experience monitoring as a space, it's to break down the silos between different groups within IT, but also within the SaaS application vendors and the companies that are using them, as well as the connectivity and service providers that are involved in the end-to-end application chain. And to be able to get those tickets that are staying open for months and really break them down from weeks of analysis and guesswork and troubleshooting into hours so you can resolve things very efficiently with your resources. So the way that is defined today in terms of digital experience observability is really a key component in an overall spectrum of a monitoring continuum for IT that starts with understanding how users are experiencing systems and all the underlying points underneath it. That's integrated with the unified endpoint management. So taking care of devices, the digital workspace, and understanding if the machine or is actually related to any of the problems that people are experiencing, as well as managing those devices and making sure they're up to date and running properly. Digital employee experience, which is the very similar to digital experience monitoring in terms of both the acronym but also the meaning. But the digital employee experience goes beyond the technology spectrum and really starts to look at engagement rates. Are employees satisfied with their job, with the overall company experience that is fueled by the digital experience that they're getting from using those applications, but also collaboration and much more than just that. So this is about really pure productivity monitoring and making sure that these are satisfied in their work. And that relates very carefully and very closely to human capital management. So understanding the sentiment, behavior of the employees, and making sure that the infrastructure around it is all supporting that initiative. So this is where digital experience monitoring fits in. And you might say, where did all those tools that I'm already using fit into this? Where did they go? Because a lot of us today are using traditional tools like real user monitoring, APM, and network performance monitoring. And those are all rolled into a completely new way to see things in digital experience monitoring. So by taking those traditional domains that looked at specific aspects of performance or user experience and integrating them together with analytics and a completely new way of deploying those, that's really centric towards SaaS in the cloud as opposed to packaged applications and traditional tiered applications. Digital experience monitoring puts new life into those kind of traditional ideas, but also changes what we would actually expect from each of those areas. So we still need to monitor how the user is experiencing applications. We need to know if the application itself is performing well or not and what's causing that problem. And we also need to know if the network's performing and is contributing to the overall digital experience or whether it's degrading it. But these are more interrelated than ever before. And that's where I wanted to have Boris explain in a bit more detail What's happened to all these traditional domains and how they're now integrated together?
Thank you, Scott. That's really a good question. Basically, all of these functions will be totally disrupted by the move to cloud, the move to SaaS, the move to public networks. So it's very interesting to see how the angle need to change basically when we look at those things. Let's start with the first one. We've got three angles: application performance monitoring, which focuses on how applications are working; real user monitoring, which focuses on how users actually reach those applications and what is the experience they're getting from those applications across an infrastructure; and network performance monitoring, which is or was focusing on how network provide a good performance to access applications in general. Let's take a look at the first one. So when we think about application in general, in a traditional mode, we would look at applications that were basically developed in-house, custom applications where our customers had control of all the stacks, all the tiers in those applications. And the key focus in APM traditionally was understanding what makes the application fast or slow to respond. And that was mostly focused on in-application transactions. So how is my front end communicating to middleware and backends, and basically what makes front end transactions fast or slow. When we look at the new world, we are going to focus on other applications. Most of them are web or mobile applications. A lot of them are hosted in different environments. A lot of them have changed the type of framework on which they are based. A lot of them are microservices based. A lot of them use massively APIs, also rely on third-party services for many functions inside the applications, and also rely on other pieces of infrastructure like CDNs as an example. And they are radically different in that sense that basically agent-based APMs do not fit in because it might be microservices led, because it might belong to a PaaS platform, because some of the functions embedded into the application may be just SaaS services that basically have the need to develop those functions inside the applications. And basically, the old APM approach doesn't apply to that new environment. Okay, so if we want to give you an example of that, I'll take a very simple example. So we're here on the Kadiska platform, and we are going to take a look at the Kadiska platform itself as an example. So the first thing we would see here is where are the users and who's getting a good or a bad experience when they load on the application, or when basically they process API calls to those applications. That's one of the first changes. Web applications do not basically use multiple pages. There are usually single page applications where you load a first frame with a JavaScript bundle, and then most of what the users are actually doing correspond to API processing calls. And the question is, what are those API processing calls? How do they evolve through time? What kind of results do we get depending on where users are? And how many errors do we get? And what are making those API calls basically fast or slow to load? So here the first thing is, okay, the number of users, what is the latency to them? And what is the average time needed to process one of those API calls? And what is the error rate? And then you see a breakdown of those based on the geography. So you see an indication of volume, an indication of errors. So that's the size of the red line. And the color will tell you basically how fast they're loaded. For example, they are going to be slower to be loaded from the US than they are from you in that case. And then when we want to start looking into those, we can look at the type of devices and where they come from or through which ISP. But most of the time, what we are going to do is look at, okay, what are those API calls that are fast or slow? So basically, how does this evolve through? Is there a trend that shows me that, for example, my application is getting slower on average? Do I see more errors? Do I see more requests? What is the distribution of response time that I get? And does it vary significantly based on where people are connecting to my application from? And then the part which is probably the most interesting is understanding where you may be having trouble. And basically you see all the host names. They might be third parties, like here you've got things provided by HubSpot. You might have things provided our own systems mixed together. And basically what is the intensity of the use of each, and what is the response time for each of them, and how they vary depending on the system or the browser used by people to connect to it. And then you see the actual API calls or transactions. Those API calls are going to be the things that are extremely important for us to measure. And if we want to see, for example, what is slow, we can simply filter and look at the ones that are longer to process than 360 milliseconds. And we would get a clear view of what are those, what are the most common ones, which are the ones that would require some optimization, and what is the infrastructure layer? Is it the application? Is it a network issue? Is it a browser issue that basically makes it slow to perform? And then we could basically look into the errors themselves and get into the full details and see if it varies depending on the platform used by users, etc. Okay, so that would be a first demo of what APM is today when in that new world, which is radically different from what it was. Okay, if we move to the second topic, so real user monitoring was really designed to show the performance from an end user experience to those applications. And traditionally, it was applied to in-house applications with a focus on one application. The deployment was made from the application side. For example, for web application, it would consist of placing a JavaScript insertion reference in the code, and that would give you an idea of where people come from and what impact it has on the experience. When we think of that new world, a lot of those applications have been replaced by SaaS applications in most cases. In other cases, they are going to be replaced by PaaS applications that allow build application much faster, and sometimes a combination of them to build what we call a composable application, which basically is going to provide one front end, which can be a PaaS platform, but that front end is going to go and basically pull data through APIs from multiple sources, which can be SaaS, PaaS, or legacy applications. In most cases, basically the application side instrumentation is simply impossible. So you've got to look for all the ways, and basically RAM has to be reinvented to be deployed from an endpoint, from a user side point of view, and also to represent the impact of all the host names into composable applications. Basically, the third-party host names, not only the core host names of PaaS or SaaS service, but also everything that can be integrated into it using CDNs and APIs. Okay, if we want a demo of that, I would take another example, which would be our CRM, for example. If we take HubSpot here, where you see a certain number of users, you see that connectivity is actually not great from most of our users, and then you see how fast we load a page in HubSpot, which is not the thing we do most frequently, but how long an API call would take to be processed. If we want to understand what is performance to HubSpot and what drives it, we would simply make a single click to applications, and then we would see basically our users getting to that application, how the page loads, the time needed to load pages basically evolves, the time to do API processing, and the percentage of error vary through time. So you can see that there was definitely a slow response from the application overall, and then we'll find out who was impacted and why. And then you can see basically how that experience varies depending on how people are connected. So whether they are remote or whether they are sitting on one of our sites. Of course, you'll see that some people working remote had trouble, a lot of connectivity hiccups, far longer times than the people working on site. And you can see two examples of that. That could be the people connected through Aldicom or connected through Vodafone España. And you could see that from a geography standpoint and see where those people are. So the people working from Spain, for example, Mobile World Congress this week, definitely didn't have a great access to HubSpot. And in that case, we would simply take a look at this and get a confirmation of that. So the people having trouble accessing HubSpot are remote people. And then we could look at individual users or focus on a given point in time. And that would give us a feel for, okay, we had people with poor connectivity on the 28th. Who are those people? Not the people based in Canada, but the people connecting from SFR, probably they're in France, and they're having trouble. So let's focus on the remote people, for example, in France. And we are going to be able to say that it's one of our colleagues called David who had trouble. And from there, we could focus on David and make a focus on him. Maybe take a wider look than just HubSpot and see how his week working has been to all the applications and see if the problem he had with HubSpot from connectivity standpoint also impacted other applications. Seemed to have impacted another application called Wallaxy, and he had trouble connecting to Notion, but that was definitely a server problem. And then basically we can see all of that evolution. So page loads, processing time, so we can see when working for him was a challenge for those reasons. We can see how his connectivity evolved, and for example, we can see that on the 27th, his connectivity was pretty bad, and we can tell exactly where he was and basically what provider he was using that was creating such trouble. So DNS was very bad on SFR at that time, and that was close to Toulouse. And we can also see CPU and RAM usage so that we get a 360 degrees view of why applications might be experienced in a poor way from a user perspective.
Great, Boris. So let's take a look at those examples. Actually, you had some network performance issues that were causing problems for David. Maybe you can take us through what a new kind of network performance monitoring would look like to help you there.
Yeah, basically what changed in network and in network monitoring as a consequence. We come from a world where most of the networks were private networks, MPLS networks. And basically, we had on site people connecting to data centers. So the focus from a monitoring standpoint was on devices that were under our customers' control or directly the ones of the service provider providing the link. And we were focusing on the link from bandwidth point of view and from a performance standpoint. So monitoring devices, monitoring bandwidth was the way to get visibility into what was going through the network. Capacity was key. And basically the routes were clear. We went from point A to point B. There was nothing to think about from that point of view. The route was clear. The responsibility of the performance between A and B was also crystal clear. If there was some kind of issue, it was easy to know who you would have to reach out to fix the problem. We basically moved to a completely different world. Whether you consider site to site or site to app connectivity using SD-WAN and hybrid networks, or whether you consider remote worker connectivity using SASE solutions, zero trust networks, CASBs, VPNs. There's one thing which changes radically, which is the use of public networks. So basically all of that, although we build overlays above it, we claim to have points of presence all over the world, rely on public connectivity, rely on DNS to redirect people to the right place. And what changes fundamentally is that using public connectivity, you don't use the network of one organization, one service provider. You use a series of networks, and the path can change anytime. The DNS resolution to a certain cloud service can change also anytime, and it's all dynamic. That's the first thing. And the second thing is it's all based on devices you can't monitor. So none of those devices are actually yours, and still they drive all the network performance for your users to reach application. So the focus has changed from a device and traffic focused to something which is more the path focus to understand exactly where problems are coming from and how you can work around it. Is it the key things are going to be, is it my cloud provider which is not redirecting me to the right place? Is it a change in the path? Is it something I can work around basically using another route, another delay? And is it something that happens on my SP side, on the CDN side of the SaaS provider, or somewhere else on the internet? And basically the thing you need to answer those questions are totally different. Let's take a look and fine. So the first thing you saw was basically a view of how remote and people access applications. So that's the first thing, is understanding where connectivity isn't good, from which ISP to which application. So for example, is my zero trust network from one of my subs providing longer latency than another? That would be an excellent question to ask in those worlds. And basically, how do we connect users on the left through gateways and cloud services and zero trust network to applications? That's going to be the key. If someone has trouble connecting from HubSpot, who are they? Where are they connecting from? And what about the people using that gateway? Are they getting a better or worse performance than people coming from Palo Alto, for example, using Zscaler? So that's going to be the key question. That tells you basically what can go right or what is actually going wrong. But then you need to find out why. And the why usually lies into what is the path that you're taking. So if I take a simple example of an application which is widely used, if I take Salesforce as an example, I'm going to show you a live map, for example, of the last, say, 24 hours and show you where Salesforce is properly accessible from the CDN and the path from Salesforce. So I can see that, for example, from Malaysia, it turns into purple. Latency is super long, so it's going to be very hard for those guys to reach Salesforce. The red indicator tell me where there is packet loss. So, for example, from Japan or from China, that's going to be some form of challenge. The other thing that I can read here is that the PaaS platform seems to be pretty accessible on average. The behavior from latency and loss point of view seems pretty stable. The access to the CDN of Salesforce looks a lot more hectic. So let's focus on this. So I just refreshed the map. I see that, for example, some people in the east side of the US have trouble, some people in Iberia have trouble. And the question is going to be why and where from. So I can take a look at all the offices that I'm monitoring, and I can see basically the change in behavior. And I can see, for example, that in India, I had a big degradation of latency. From Singapore, I've got a huge outage. So if we focus on those two places, which I could have seen with the first screen I showed, the question is why and what can I do about it? And basically, to understand what I can do about it, I'm just going to have to understand what is the path that I'm taking and why am I getting to those horrendous latency rates, which means people basically can't use those things or are going to have an extremely slow response. And there is a lot of packet loss. So what I see here are my remote sites. And then I see basically each dot is going to be a router, each color corresponds to an operator, an autonomous system, and each point on the right corresponds to a different DNS resolution for the same Salesforce service. And the question is going to be, what is happening when I have those tremendous latency and loss? And where is it coming from? And basically what I can do is just do this and see, okay, the latency is actually being dramatically impacted at the exchange, the internet exchange in Singapore to reach this CDN node of Salesforce. So what I can do is I can raise a ticket towards Salesforce because it's their responsibility. I can clear the cache of my browser, try to have user refreshing, getting another DNS resolution, hoping they are going to be connected to another node and not go through that. And in the case of Nashik in India, so it's going to be the red curve, I'm going to flag another time where there is a lot of packet loss this time. I'm going to find out where. Basically, I can see it's right before the CDN node here on the Telstra network. So again, it is definitely Salesforce's responsibility. If this had been identified, for example, on the last mile, say on the Reliance GIO, who was the ISP for that site, and I'm using an SD1, I could have basically worked around it by using the second underlay and use another operator to get to another route, basically another destination to reach the Salesforce service. Okay, so that's what NPM would look like today. We don't care so much about bandwidth. Basically, all is encrypted, so what we can get from the traffic is limited. So the focus is really on response times and having the proper response time from a network standpoint to reach the services that matter.
Thanks, Boris. That's awesome. It's important to see what's available now so you can really solve those problems quickly. I think it's about what you're pointing out is you're going to be dealing a lot of the time with third-party vendors, whether it's Salesforce or your ISP or people that are managing your SD-WAN, for example, even internal groups if you're developing your own web-based application. So it's really about having the evidence you need at a moment in time to have a really good productive conversation with those vendors, help them identify quickly how to solve that problem with their own trouble tickets. And it's very hard to raise a ticket to Salesforce and say, I'm having a bad day. They're not going to do very much about that. So providing much more detail about it being part of their CDN group, like Boris has shown, or it's a server related issue, can really change an awful lot. And we see that in real world application troubleshooting all the time. So I want to just take you through a quick view of the benefits. Here you see the overall picture of what digital experience monitoring today looks like. The key aspect of this is the integration, the ability that Boris showed you of going from a user's experience, application performance issues, identifying whether the server, the network, the device, the browser, applications, plugged in applications, where is the actual problem coming from, and then being able to go down to those transactions and get the evidence you need to resolve them. That's really fundamental, and so is the path visualization. It tells you more than just, is the link up or down and what's the speed test tell me? It's actually, where did the traffic actually go and where along that route did things go wrong? So there's benefits to digital experience monitoring are quite wide ranging. That's why it's such a fast growing space. What we're seeing is today about 20% of organizations are using digital experience monitoring, but within 3 years, we will see that rise to about 70%. And that's an interesting testament to the power of this kind of solution. So IT teams can really accelerate their problems far faster. They can focus their resources so they're not just chasing ghosts and making hypothesis and testing. They're not just trying to prove that the network is actually responsible or not. So the proof of innocence gets off the table, and it really helps people work towards a common goal and keep the complexity down. So we have a lot of tools today already, but using 2 or 3 tools to solve a problem won't work anymore if they don't have full visibility of what's happening across this infrastructure. But for the business, it's actually the reason why there's budget being carved out for this now. It's more because productivity is critical in a digital world. We are very dependent on a digitally transformed, cloud-enabled environment. You want your employees to be productive, or actually they'll just resign. We see that about a third of them, people leaving companies, are because they feel they can't be productive with ancient systems that are not behaving. So when you're loading Salesforce and it takes over a minute to get the page up and running, that's the kind of thing that can drive people nuts and lose their engagement. So bringing the enhanced digital workspace to everyone in the organization, wherever they are, and then driving customer satisfaction through very effective, responsive systems that let you serve your customers better is really the goal for digital experience monitoring in general. So I wanted to just wrap up here with an invitation to the attendees today. If you're interested in trying out that platform, you can certainly get a free trial from us, and we can take you through an assessment of what digital experience monitoring can do for your specific business applications and how you'd be able to monitor those and identify bottlenecks within minutes of getting the platform set up. So a very simple 5-minute exercise of getting onboarded, and then we can take you through that, and you can explore your world with a lot different lens, basically seeing it in a higher resolution than you would normally see with traditional tools. So I'd like to thank Boris for the excellent demos there and for the insights on the traditional tools and how things are changing. So Boris, thanks for your time, and thank you everyone for joining us. And the recording will be available. And if you guys are looking for any more resources on digital experience monitoring, please visit the website. We have a large collection of resources related to what it is, but also in specific use cases and how it can help you troubleshoot your employees' experience. Thank you, everyone. Have a great day.